You know when you're shopping online, viewing a list of products and you click on a brand, and suddenly the available sizes and colours update automatically? That kind of filtering is dynamic filtering. And if you're building product listings or dashboards, you'll want to know how to implement it properly in your database and SQL. In this video, I'll show you exactly how dynamic filtering works. We'll walk through two different database design options, write the SQL to make it work, and I'll explain the trade-offs between flexibility and performance. This approach works whether you're building an e-commerce site or an analytics dashboard. If you want to get better at database design, grab my free project guides in the description. Let's get started. Let's say we're building a product listing page. We've got a list of products such as shoes, shirts, or jumpers. The user should be able to filter by category, brand, size, and color. Here's the key part. The available filter options need to update based on what's selected. So if they pick Adidas as the brand, the size and color filters should only show values that actually exist for Adidas products. We also want this same logic to work in a dashboard. For example, selecting a region updates the available sales reps and products. This is a real-world problem, and you can solve it with the right database design and a few smart SQL queries. Let's start with the most common approach, which is using separate tables for each attribute. This works well when your attributes are stable and predictable, and if you've got good software deployment practices. Here's what our schema looks like. Each product links to a category and a brand. Sizes and colors are also stored in separate tables, one row per combination. This makes it easy to run queries and keeps your data types clean. Now let's say a user selects shoes as the category and Adidas as the brand. We want to show all Adidas shoes on the page. Then for the filters, we want to show sizes and colors only for Adidas shoes. This gives us all products that match both filters. Now, how do we populate the list of available sizes? Here is a query. We can see here that we are filtering on the category of shoes and the brand of Adidas. We then get the distinct list of sizes. The same logic applies for getting a list of colors. This gives us dynamic filtering, which is completely based on the user's current selections. What if you selected a value for one attribute and wanted to see the available selections for the other attributes? One way would be to not add this functionality. You would show all possible selections, all possible sizes and colors, and if there are no products that meet this combination, you would show no results. But let's assume you wanted to do this. How would you write a query? Let's say you wanted to see all sizes for your selected color. Your query may look like this. You have a subquery that limits the products based on the selected color. However, this could get messy pretty quickly. You could redesign this query to use a CTE, or maybe just join to a subquery that does the filtering. Or maybe there's another way to do it. The traditional model works great, but sometimes you'll want more flexibility with your attributes, or want to adjust attributes without having to go through a lengthy database deployment process. That's where the generic attributes model comes in. Instead of separate tables, you store all the attributes in one table. This is also called an entity attribute value design. Here is the database design for it. We have one table for products and the same category and brand tables. This is because they always exist for products. Then the rest of the attributes are in the product attributes table. This contains the sizes, colors, and more. This gives you full flexibility. Do you want to add a new attribute like material or warranty? You can add a new record to this table. No schema changes are needed. But the trade-off is you give up strict data types and the queries get more complex. Let's run the same filters. Category is shoes, brand is Adidas, and we want the available sizes. The query to get Adidas shoes is the same as before because the category and brand tables are the same. Now let's get the available sizes. Here is the query. We run a query on the attributes table, joining to the products table, and select the attributes where the name is size. You could do the same for color, material, or anything else. You can just change the attribute name. So which of these approaches should you use? Let's compare them. The traditional approach with normalized tables has lower flexibility, simpler queries, higher performance, data type safety, but needs schema changes for new attributes. The generic or EAV method has higher flexibility, slightly more complex queries, lower performance, weaker data type safety, but no schema changes are required. So which one should you use? Use the traditional model if your attributes are known, stable, and you care about performance. or if you have a pretty good deployment process which allows you to alter the database schema pretty easily. Use the generic or EAV model if your attributes change often or you don't want to update the schema every time you need to add a new product feature or attribute. I've covered this EAV design in more detail and some options in another video, which I've linked in the description. Designing databases based on real scenarios like this is how you really improve your skills. If you want to get better at designing databases, grab the free project guide I mentioned earlier. The link is in the description. And if you want to go deeper on why EAV designs are usually a bad idea and what alternatives you have, watch this video next. Thanks for watching.